All right, let me turn my web. Here, hold on. Off goes the camera. Chapter 14 homework?
Yes.
Did we skip a chapter? Weren't we on chapter 11?
No, we did 13 last week.
Oh, we did 13 also? Okay, now I'm kind of remembering it, yeah. Well, this seems rather easy compared to what they've been asking.
Yeah, so it would be C sub 2, correct?
They want an absolute
maximum.
maximum.
So it's going to be sub 3.
Mm-hmm.
And then continue.
This would be C sub 2. Mm-hmm. Whoops. See, I did it too quickly. If we look at this, is that an absolute minimum?
Potentially not, I guess.
Well, it's a local minimum because there's points to the left and to the right that are higher than this point. But it's not an absolute minimum if we compare it to the endpoints. And in fact, these endpoints, because of those arrows, they keep going down. So there is no absolute minimum in this function.
Okay. So if it had asked local minimum, then it would have been C2?
Yes.
Okay.
How are the previous two answers consistent with the extreme value theorem? Well, the interval was not closed.
Would it be A, I think?
No, because there was no absolute minimum. So I'm going to say D. The interval's not closed because it goes from negative infinity to infinity, apparently. Therefore, the function need not have both extrema. Extreme value theorem says that on any closed interval there will be an absolute maximum and an absolute minimum.
Could you repeat the extreme value theorem again, just so I can write that down?
I think, here, let me look it up, just a second. Make sure I have it exactly correct. It says, if I'm remembering it correctly, that on any closed interval, there will always be an absolute maximum and an absolute minimum. 164, hold on. If f is continuous on a closed interval, then f has both a minimum and a maximum on that interval. So this is not a closed interval, otherwise we would have had an absolute minimum. Since we know that there wasn't any there, then the interval is not closed, therefore it need not have both extrema. If we'd have said the interval between C1 and C3, then we would have been able to find the absolute maximum and the absolute minimum. We might have had to check the endpoints. So it depends on whether that interval is closed or open.
Okay.
What's the difference between relative extrema and an absolute extremum? Is A correct?
It sounds correct, yeah.
Well, it can't really. If you think about it, absolute means there's only going to be one.
Okay.
So it can't have more than one absolute. It can have more than one local, but it can't have more than one absolute. Let's look at B. A continuous function can have more than one relative maximum and a relative minimum, but does not always have an absolute. B looks correct to me. Whoops, no. If it's on a closed interval, it has to have an absolute maximum and minimum. So C can have more than one relative, yes, but it has only one. C looks right to me. Yeah, C is the only one that's even close. Wow, it's the first time we've ever gotten a fantastic with an explanation.
Nice. So that one, it can have an absolute maximum and an absolute minimum, but not more than one of each?
Yes.
Okay.
It necessarily will have one.
Okay.
Of each on a closed interval, and only one. Obviously, relative minimums and maximums, you can have as many of those as you want. Find the absolute maximum and minimum on that interval. All right. What is the derivative of this function?
So it's going to be 4x cubed minus 64x. That's it.
Okay. So what we know is that on absolute extrema, or local, in fact, relative extrema, what do we know about the first derivative? What's it going to be on those?
What do you mean, as in like?
It's going to be 0. In other words, if I take a function and I say, okay, here's my function, where's the extreme maximum occur? Right here. But what happens there? If we draw the slope of the tangent line, that slope is 0. So the way we find extrema is by taking the first derivative, setting it equal to 0, and solving for those points. Okay?
Okay.
So if we set this thing equal to 0, and then factor out of 4x, and then factor that more, and since that's the difference of squares, how does that factor?
It's just x plus 4, x minus 4.
So where are my solutions?
0, 4, negative 4.
0, negative 4, 0, and 4. And are all of those in our interval from minus 5 to 5?
Yes.
Okay. So the first thing they want is the absolute minimum.
So
Now,
that would be negative 4.
Why that?
I'm just assuming because it's the lowest number.
Well, not necessarily. In other words, if we have a graph like this, then over here at -4, we're going to have high values for f of x, whereas at +4, we would have lower values. So we can't use that. We have to try to determine whether we can use the first derivative test or we can use the second derivative test. The second derivative test says that if a function has a maximum that's concave down, second derivative is going to be negative. If a function has a minimum, right here, first derivative is still going to be 0, but the second derivative, because this is concave up, the second derivative must be positive at that point. So I've always found the second derivative test to be the far easier test. So let's use it if we can. What is the second derivative of this?
12x squared minus 64.
At x equals 0, what is the second derivative, positive or negative?
Negative 64.
Okay, so that means that is a maximum because the second derivative is negative. Negative means concave down. Concave down means it's a maximum. What is it at -4? And the only thing we need is positive or negative. So f double prime of 0 is less than 0. F double prime of -4 is greater than or less than 0?
It's going to be greater, right?
Yes. Yeah, because -4 squared is 16, and 12 times 16 is a bigger number than 64. So at -4, that's a minimum. And +4 we can see is the same thing. So the second derivative at +4 is also greater than 0. So that's a minimum. So we might have a curve that looks something like this. We know our, what did I just say? I said
-4 and 4.
Those are minimums. Okay. And the maximum was there. So here's -4. Here's 4. So this curve might look something like this.
Wouldn't -64 be, like, wouldn't that be?
It's not a question of the size of that second derivative. It's merely a question as to whether it is positive or negative. Let me show you this thing again.
Yeah, I guess I just think that it should be mirrored over the x-axis, so we
Right.
drew it.
Okay, let's look at this function. Here's the function. We can see
So
we can see
drew
we have a
the
maximum
second
there.
derivative.
We have a minimum there, local. That's a local maximum. Notice it's not an absolute maximum because over here it's higher. But on some closed interval, that would be a local maximum and an absolute maximum, excuse me. And this would be a local minimum. Notice that this is concave down. This is concave up. Well, if I take the first derivative and set it equal to 0, I get these 2 points right here. If you can see my hand, there's one of the solutions, there's the other solution. Well, how do I know that that's a maximum? Well, I can apply the first derivative test, which says the slope has to go from positive to negative, and that means it's a maximum. Or the first derivative test here goes from negative to positive, meaning that would be a minimum. The second derivative test, notice that if I take the second derivative and go all the way down, I'm in negative territory. So at this point here, the second derivative is negative. And that means that the original function was concave down at that point. And notice the second derivative here goes down and it's in positive territory. And I don't care how positive. In other words, I don't care what y double prime is here. The only thing I care is that it's positive. That means that that was the concave up. This was the concave down. That means this is the minimum. That's the maximum.
Okay.
Okay? So that's the logic we're going to use. So the function has an absolute minimum. Well, there's one other thing that we need to test, and that is that what if I didn't draw this right? What if this thing looks like our interval is minus 5 to 5? Well, we knew we had a local maximum there, and we know we have a local minimum here, but what if it goes like that? In other words, we know we have a flat slope there, but there's no guarantee that it doesn't continue to go down. In other words, if I'm looking for absolute maximums and minimums here, I have to not only check the places where the first derivative is 0, but I have to check the endpoints. And now it is important to find out what that number was. Well, what do we have? We had 12 times 16 minus 64. What is that? 12 times 16 is 192 minus 64 is 128. So in other words, f double prime of minus 4 was 128. But we didn't check minus 5 and 5. We need to check the endpoints. It's possible that these will give us, hold on. Back up a moment. I don't want to use the second derivative here. I want to use the function. In other words, what I'm suggesting is that f of minus 4 is possibly the lowest point on that interval. It was the candidate for the lowest point, minus 4 and plus 4, but we didn't check minus 5 or plus 5. So first of all, let's check minus 4. What is f of minus 4? Well, that's 16 squared, so it's 256 minus 32 times 16 plus 256. That looks like 0. 16 times 32 has to be 0. So f of minus 4 is equal to 0. And I know that f of 4, the other local minimum that we found, is also equal to 0. Right? What is f of minus 5 equal to? If f of minus 5 is a lower number than 0, then it represents the minimum. Can you see that? Okay, so minus 5 cubed is 625 minus 32 times 25
It's
plus
not cubed, it's the...
yeah, to the fourth power.
Yeah.
I did that. Minus 5 to the fourth power is 625.
Oh, okay, okay.
Okay. So what is 32 times 25? 800. So I have 625 minus 800 plus 256. That's a bigger number than 0. Right?
Yeah, equals 81.
Okay, so that's not going to be our relative minimum or absolute minimum. And f of 5 is the same thing, also 81. So I've checked all of the extrema, and I've checked the endpoints. And nothing produces a lower value than 0. So minus 4 and plus 4 are absolute minimums also. So can I put minus 4 comma 4, or do I need parentheses?
No, just
No, I don't
minus
need
4. Comma.
Yeah, I don't need parentheses. It's not a coordinate that we're putting. And it was necessary to go through every single step there. In other words, you have to not only check the places where the first derivative is 0, but you also have to check the endpoints. The function has an absolute maximum. Well, it's tempting to say 0, but we didn't check the endpoints, nor did we check what this function is at 0. So what is f of 0?
F of 0 is 256.
Okay. And now what is, we figured out f of minus 5, but we didn't put a number on it. However, I can tell by looking at this that it's
81.
not, oh, we did put a number on it. You're right.
Yeah.
So that's 81. It's not as big as 256. Therefore, that extrema point is higher than the endpoints. And that's our answer. Okay, let's go through exactly the same process. Only let's see if we can get you to do it, most of it here. What's the first step going to be?
Alright, so to take the first derivative
Okay.
and so you do the, I always get confused with the exponent when it's a fraction.
Okay, treat it just like it's an integer. In other words, multiply everything, multiply 1/3 by this function, subtract 1, so you end up with negative 2/3. But then we have to apply the chain rule also. Because we're going to take the derivative of the outside, which is the following. Here's the derivative of the outside. Get that?
Yeah.
Times the derivative of the inside. That's all the chain rule is. Okay? So, this is what? It is 2x on top, and it is 3 times x squared plus 9 to the 2/3 power on the bottom. Where are the critical points? In other words, if I set that equal to either 0 or undefined, and notice that there's no place that it's undefined. There's no way we can make the denominator 0. No value of x is going to give you a 0 denominator. So that's not one of our critical points. The only critical point is that which makes the numerator 0. So x equals 0 is the only critical point we have.
Okay.
Okay? Now, is that a maximum or is it a minimum? Well, let's plug it in and find out, and then check the endpoints and pick the highest number amongst the three values. We don't actually need to know whether this is a minimum or a maximum. It's one of them, and I could use the first derivative test or the second derivative test, but notice the second derivative here gets complicated rather quickly because now we have to use the quotient rule, and using the first derivative test isn't so easy. But notice that I don't need to tell whether this is a minimum or a maximum. I know it's one or the other, but because I have to check the endpoints, because my minimum or maximum may be at those endpoints. So first of all, let's check f of 0. What is that value?
It's going to be 9 times 3, 27.
It's the cube root of 9. In other words, if I plug in 0 for x, I get the cube root of 9. What is that number?
Oh, what about the...
Well, we haven't checked the endpoints. Yeah, what about what?
The 3 on the outside of the denominator.
That's the derivative function, not the original function.
Oh, okay.
When we're checking for absolute maximums, we're going to check our 0 point in the original function, and we're going to check these two endpoints in the original function. Whichever gives us the biggest number of those three, that's our absolute maximum.
Okay.
Okay? Well, the 0 point gives us cube root of 9, which has got to be, what, 2 and change, since 2 cubed is 8. Now let's check in the original function this endpoint, minus 1. Well, minus 1 gives us what? And you plug in minus 1 for x.
8, cube root 8.
No, minus 1 squared becomes plus 1. So it's cube root of 10. That's bigger. So far, the minus 1 is higher value than at x equals 0, but we need to check the other endpoint. And we can tell this is going to be a bigger number altogether.
Yeah.
This is cube root of 34. There's your biggest maximum at x equal 5. Now, notice that that is not where the first derivative is flat. In other words, the function that we're liable to be looking at here we had a low point. In other words, maybe something like this. And our interval is minus 1 to 5. In other words, we were indeed flat right there, and it looks like that was probably a local minimum, but the value at 5 is much bigger, as is the value at minus 1. This value here was cube root of 9. Not that I've drawn it like that, but so, okay. The absolute minimum occurs at
0.
Yes, and there's nothing further for us to do. We've already checked the values at the end points. We know that those are both bigger than the value at 0, and we know that 0 has to be either a minimum or the endpoints. So find the absolute extrema as well as all values of x where they occur. So it's asking the same thing that every other question has been asking. What's the first derivative?
So it's with the natural log, isn't it? 1/5.
There's no natural log here. This is e to the minus 5x.
Oh, okay. So it's negative 5x squared.
Okay, we're going to do this since there's a plus sign in between these two functions. We're going to take the derivative of that, and then we're going to take the derivative of that and add it. So the derivative of x is 1, right?
Yeah.
Plus, now what's the derivative of the outside?
That would be 5ne.
This is the derivative of the outside. Notice that e to the x is always its own derivative. So even if I want to call it e to the u, the derivative of e to the u is e to the u.
Okay.
Okay, but now I have to multiply that by the derivative of the inside. Well, what's the inside? This is the inside. So the derivative of the inside is, that's where you get your minus 5. So now I can say minus 5. Okay, so that's the derivative of that function. And the interval we're checking is minus 2 to 2. So first of all, let's find the 0 points. We'll see if we can find a place on that function where the slope is flat.
Wouldn't be 0, would it?
Well, if we solve this function, we move the 1 to the other side. Divide both sides by negative 5. Now we can take the natural log of both sides. In other words, to solve this is not that easy. You need to take the natural log of both sides. Let's do it this way. So I've got the natural log of 0.2 on the left equals the natural log of e to the minus 5x. Well, since the natural log of e is 1, basically I'm going to use my rules of logarithms to bring this minus 5x in front. So now I have the natural log of 0.2 equals minus 5x times the natural log of e, which is 1. So now I can solve for x. X is equal to the natural log of 0.2 divided by minus 5. Do you have that on your calculator?
Yeah.
It's a positive number.
Hold on, I did it backwards. .3218.
Okay, so we know that at x equal this value, we have a zero slope. That's all we know. We still have to compare that value with the endpoints. So this is our critical point, x equal 0.3218. So now let's evaluate the function. What is f of this point? Can you do this on your calculator? Where you plug in x of 0.3218?
.52189.
Now what's the next step? Check the endpoints.
Oh yeah.
So it's f of minus 2. So that would be minus 2 plus e to the 10th power. Pretty good sized number.
Yeah, 44,050.934.
Well, at this point, that's looking like a good choice for the maximum, but we got to plug in plus 2.
Alright.
Now, go ahead and plug it in. I can see that now it's 2 plus e to the minus 10th. E to the minus 10th is a very, very small number. So f of plus 2 is what?
2.0, continuing for a while.
Yeah. All right, so now we can pull out our absolute maximum. Where does the absolute maximum occur?
-2.
Oh, man, it's going to make us answer this question. That is not a good thing. Decimal rounded to 4 decimal places. This answer of 44,050.93, what were the next 2 decimal places after that?
So rounded to the 4th would be .9316.
So are you comfortable saying 44,050 point, what was that again?
9316.
Okay, so that is the absolute maximum. And it occurs in an x value of minus 2, correct?
Yes. Huh.
So it's telling us to do exactly what we did. So let me put this into Wolfram Alpha and come up with a value of this thing. We have minus 2 plus e raised to the 10th power. Now I got 22,024. See this answer?
Yeah. Oh yeah, I did get that.
22024.4658.
Yeah. Yep, that's right. I don't know what I did, another extra step or something.
Yeah,
'Cause
you
I have
doubled
that
it.
in my calculator.
You doubled it. This is half of that number you gave me.
Ah.
So this is 22024.4658. 4658. Okay. Absolute minimum. Well, we've done most of the work. In other words, there was only one critical value. So the only candidates for an absolute minimum are this value at x equal 0.3218 or one of the endpoints. Which one is it?
I think it's the 0.3218.
Yeah. Let's put that into Wolfram Alpha. Hold on a moment. What we want to put into Wolfram Alpha is lost my train of thought here. Minus no, we just want E raised to the oh no, now I remember. It was the natural log of 0.2 divided what was it when I had you do that? Natural log of 0.2 divided by minus 5.
Yeah.
And this is the value of the x. 0.3219 if we round it off. So it occurs at 0.3219 and its value was 0.5219. And that should be the minimum. 0.5219. 0.5219. Okay. First step.
Take the derivative. It's going to be 6 over
Okay.
X.
Remember, we've got to use either the quotient rule or the product rule. Now, I have a little trick to avoid using the quotient rule. And that is, I'm going to write this function like this. Now notice that I can use the product rule. You remember the product rule? If y is equal to u times v, then y prime is u prime v plus v prime u, or plus u v prime. So the product rule is it's one times the derivative of the other plus the reverse. Okay? With me?
Yeah.
Okay.
What was the last part of that? You said y prime
If y
equals
u times v, then y prime is this times the derivative of that plus the reverse, or since the associative property holds, I could say that it's u prime times v plus u times v prime. In other words, the product rule is pretty easy to remember because you can do it in any order. It's just one times the derivative of the other plus the reverse of it.
Okay.
Okay? So let's use the product rule since it's considerably easier than the quotient rule to get y prime. So it's best to use some sort of a system here. I always take that times the derivative of the other. So we'll start off with u. And what is the derivative of this part here? It's the derivative of the outside.
So that'd be x squared plus 36.
Well, with a negative 1 in front of it. So that's the derivative of the outside. And what happens when I take away 1 from the exponent? What do I get?
Over 1.
Minus 2. If you start with minus 1 and you subtract 1, you get minus 2. So that's the derivative of the outside. I still need to take the derivative of the inside because I still have to apply the chain rule even if we're using the product rule. But the derivative of the inside is 2x. Okay, so far so good. I've done this part. I haven't done the second part yet. I still have to do the u prime times v. Okay, so what is that?
So that would be just the opposite, as in negative, positive, or?
No, by opposite I mean the first case I took 6x times the derivative of the second part of the function. Now I'm going to take the derivative of 6x times this part of the function. So it's just 6 times whatever this is, which is x squared plus 36 to the minus 1. So now I got the whole thing using the product rule. And if there's any part of that you don't understand, we need to stop and cover it. Because this stuff is really more important in terms of calculus than all of these fancy questions they're asking you.
Okay.
Okay, you absolutely need to know how to do the product rule to find the derivative of this. So let's just review it again. So I started with 6x times the derivative of this plus the derivative of 6x times this. Okay?
Okay.
Now let's simplify. I'm going to put my positive term first. And since the first term had a negative sign, I'm going to subtract 6x times 2x. Well, that's 12x squared. Now I've taken care of this and this. And I have to still multiply it by x squared plus 36 to the minus 2. So there's my y prime. And what does this look like? This looks like this. See that?
Yeah.
Okay. So now I got to set that equal to 0. Well, notice that the denominator is always going to be positive. Well, actually, that's not quite true. Each of these denominators is going to be positive, but I still have some solving to do to solve this equation. Have to have a common denominator, right?
Mm-hmm.
In other words, I got to change this denominator into squared. So I'm going to multiply top and bottom by x squared plus 36. So now I've got 6x squared plus 216 all over x squared plus 36 squared. See how I turned that term into this?
Yeah.
Okay, minus 12x squared over the same denominator. Now I can say that the only way this thing can be equal to 0 is if my numerator is equal to 0. So what has to be 0? If I simplify this numerator, I have minus 6x squared plus 216. I'm honing in on it. So x squared is equal to 216 divided by 6. 216 divided by 6 equals 36, positive 36. So x equals what?
6 or negative 6.
Plus or minus. Always try to get in the habit of putting that plus or minus whenever you're solving an equation where you had to take the square root of both sides. It's plus or minus 6.
Okay.
Okay, so there's our critical points, plus and minus 6. That's where the slope of the tangent line is 0. Now,
Couldn't we have just looked at what would make the denominator 0?
nothing makes the denominator 0.
Oh, yeah, you're right.
Not in
Yeah,
the original function and not in its first derivative. In other words, after we took the first derivative, here was our denominator, x squared plus 36 squared.
Is it a coincidence that x squared plus 36, like,
Yes.
just from out of the denominator could be...
It is a coincidence. I'm pretty sure it's a coincidence.
Okay.
Yeah. In other words, but you'll notice that even with x being plus or minus 6, it does not make the denominator 0. Because even the minus 6 squares to a plus 36. Okay. So, we don't have an interval on this one. Okay, so they want the only place the absolute extrema could occur would be where that slope is 0. And we know that that is...
Would I need to plug 6 in? Or negative 6?
Well, we got two choices here. First of all, we know that plus and minus 6 represent an absolute minimum, and one of them is probably an absolute maximum. Or they could even both be absolute maximums. If the function looks something like this, like that one they gave us, both of these points have 0 slopes, and they're both absolute maximums. But this would have had a third zero slope right there. So this function does not look like this. But it's still, we don't know whether we're dealing with maximum or minimums at these values. So we've got two choices. We can apply the first derivative test or we can apply the second derivative test to determine whether we don't even need to do that. If I tell you that one of these is a maximum and one of them's a minimum, which one is the maximum, which one is the minimum?
I think the minimum is going to be negative.
Right. Plug it into the original function, and you'll notice that when you plug in the -6, it makes the numerator negative. That's going to be a negative number. When you plug in the +6, it makes the numerator positive. That's going to be a positive number. So we know -6 is the minimum. +6 is going to be the maximum, just by looking at it and plugging them in. Okay, the function has an absolute maximum at the point +6.
So 0, 6.
Where's the 0?
I want you to type an ordered pair.
Well, there's only one maximum. There's not two.
No, it means like an ordered pair.
Yeah, I know, but it's only one number. It says type an ordered pair, but we don't have, okay. Oh, the ordered pair would be 6 and the y value of 6. Okay, I get it now. And this is where I do need parentheses, I think.
Yeah.
So the maximum occurs at 6, and what is that maximum? It's 36 over 72. It's 1/2. So this would be 0.5. 0.5. So there's the ordered pair for our maximum. And the function has an absolute minimum at what?
-36. Well,
-6,
comma. Then it'd be -30 or -1/2, -0.5.
All right. In other words, there's more than one way to skin that cat to determine which is the minimum and which is the maximum. You got a first derivative test, you got a second derivative test, or you can just plug in both values and whichever one comes up the smaller one, that's going to be the minimum. Let's see, we're going to go to 745, is that right?
Yeah.
Okay. Okay, so we have a profit function. Find the number of hundred thousands of pillows. So we don't actually need to put that in. That must be sold to maximize profit. So if I'm going to maximize a function or find the maximum value, I want to find where the slope is 0, and I want to find the endpoints.
So we're going to take the derivative,
which is?
It's going to be, I'm going to write it out. So p of x equals -x cubed plus 9x squared Okay, so p prime negative 3x squared plus 18x plus 120.
Okay. Where x has to be greater than or equal to 5. In other words, if we come up with a value of 3, we can't use it. So what's our next step?
Solve for x to
Well,
find
we need to
1.
set this 0 and then solve for x.
So you can pull a 3 out.
How about let's
3
pull a
out.
negative 3 out and change everything to positive numbers. Right?
Yep.
And that factors how?
X minus 10, x plus 4.
So our two values are,
Wouldn't it be 3 values? 0,
no,
negative.
0 is not a solution. In other words, starting from here, we have a quadratic. There's only two solutions to quadratics. In other words, I wasn't able to pull an x out, so I did not have an x in front. In other words, I'm solving this equation, and the solution gives me x can be equal to either 10 or negative 4. Well, the negative 4 is not in my domain. Besides, I can't produce negative 400,000ths to increase my profit. But this tells me that my maximum profit occurs when I produce 100,000 pillows. Well, in other words, when x is 10, I'm going to produce my maximum profit. Well, what is P of 10? In other words, this step, which can be difficult to remember, I remember going through it, is once you've solved the first derivative for 0 and you come up with a value for x, you have to go back to the original function and plug in that value to figure out what that profit's going to be, right?
Mm-hmm.
So what is this? It's minus 1,000 plus 900 plus 1,200 minus 300. That's 2,100 minus 1,300, that's 800. So our profit is going to be $800,000. I didn't make the same mistake as I did before. The maximum profit will occur when 10 pillows are sold.
It'd be 100,000.
I did make the same mistake. 100, find the number of 100,000s of pillows. So there's 100,000. 1, 2, 3, 4, 5, 6.
I think it's just 100.
There's one too many zeros. It's 5 zeros. Okay. Okay. Problem sounds hard and complicated, but it's the same as everything we've been doing. Since I am given a function and they want the maximum length, L of t is the length of this molar. Okay, so if I want to know when the maximum length occurs, I want to take the derivative, set it equal to 0, solve for t. Okay, so what is L prime of t?
.3t, negative 0.3t plus 1.33.
Okay, so solving for that, pretty easy. So I get negative 1.33 equals negative 0.3t. So t equals 4.43333. So in other words, notice the last sentence. What's the maximum length of these molars in weeks 30 through 60? Well, we just figured out that the maximum is going to occur in week 4.43. So that's not going to be my answer. In other words, in weeks 30 through 60, there is no place where the derivative is equal to 0. The derivative is equal to 0 at only one spot, and that's at time 4.4, weeks after conception. So how am I going to figure out what the maximum length is in the periods 30 through 60?
Would you just, no, I was
Yeah,
going to say
no,
multiply it.
Well, figure out what the function at 30 weeks is, figure out what the function at 60 weeks is, and take the largest number. Because we know that between those two periods, there is no flat spot. So the largest number has to be at the end points, right? You can't draw a function that doesn't have a flat spot where the maximum isn't going to be at one of the endpoints. So let's find L of 30. I'm going to do that on Wolfram Alpha, or can you do it easier on your calculator?
I can run my calculator.
Okay.
And just regular L, right? Not prime.
Yes. Plug in 30 for t into this function right here.
$32.15.
What's the third decimal?
That's it.
0.
Yeah.
And what's L of 60?
$71.6.
I was going to say, one would think that these teeth would keep getting longer. I would expect the maximum to occur at L of 60.
Yeah.
Now, if we calculate what L of 4.43 is, that would give us probably a minimum is my guess. But anyway, it's unimportant because that is not in our domain, 4.43. So our answer has to be 60. Our answer has to be 71.6.
Comma 60. Oh no, that doesn't ask for an ordered pair. Just double check the math, I guess. So it's negative 0.015 times 60. Oh, squared. I didn't see that. Plus 1.3360 minus 7.3. 18.5.
Let's do the 31 again. Make sure that that's not a bigger number.
I think it might be bigger only because, yeah, 19.1.
Cool. I guess their teeth don't get bigger. So we want 19.1, right?
Yeah. Oh my gosh.
Yeah, let me put it into Wolfram Alpha. So I've got negative 0.015 times 30 squared. That's 900. Plus 1.33 times 30 minus 7.3. Okay, I get 19.1 also. Now let's do 60 squared. So this would be 3,600, and this would be 60. And I got 18.5, just like you did.
Hmm. I wonder if it is 18.5 because if you did like parenthesis 30 comma 60 parenthesis, it wouldn't include week 60, so it would be everything up to then. So what if it would be 18.5? Oh, it says through week 60 though.
Yeah. I am a bit curious to figure out what L of 4.433 is. Let me do that in Wolfram Alpha. So this needs to be 4.43 raised to the 2 power. And this is 4.43. Gives you a negative number. So that was a minimum. And it wasn't in our interval anyway. Couldn't possibly want 2 more zeros here, could they?
Perhaps.
30 squared, there's the negative sign, 0.015 times 900 plus 1.33 times 30 minus 7.3. 19.1. How is that not correct? How is 22.18 correct? They're saying that there must be a point between 30 and 60 In other words, they're saying that this function has to look like this. We know that at 30, it's 19.1, and that at 60, it's 18.5. They're saying that there's a higher spot in there, where this spot here is 22.182. Well, notice that the slope is 0 there. That's the only way you could have a value between 30 and 60 that gave you a higher L of t than these endpoints. There's no way to draw this thing so that you would not have a flat slope. You see why? I cannot connect these two dots. In other words, I have a dot here and a dot there. Those are my two endpoints. There's no way to connect those. In other words, if this is the maximum and this is the minimum, I cannot let that curve do that because that means there's a flat slope there. The only way I can get from one point to the other is somehow doing that where there's no flat slope, which would guarantee that that is my maximum because I did not find a 0 slope in that area. I found a 0 slope at 4.4333. Well, I wonder if I did that wrong. I was off by a factor of 10. I just realized when I found that. If we go back to this step right here, it's not 0.3, it's 0.03.
Oh, man.
Which means I'm dividing by 0.03, which means my answer is 44, not 4.4. And 44 is in our domain. So,
oh, man.
Yeah.
You know what? I'm the one that actually said that gave you that, so
well,
I guess it's my
it's another just another example of they're testing our arithmetic here, which is not really what they want to be testing. They want to be testing our knowledge of calculus. And they made the arithmetic so hard that we screwed up on the arithmetic. It's not really your fault. It's just that explains everything. So the maximum length occurs right there at 44.333. And what is that number? I'll give it to you in a second. It's 44.333 squared. So the answer is 22.182. Exactly what they said. Okay, so we need to do a similar exercise, right?
Yeah, at least we know the...
Yeah.
We did it right, at least.
Yeah, they didn't make it that hard. They didn't make it that different. So we want to take the derivative of this. So we have minus 0.03 t plus 1.28. So we're going to set that equal to 0. So I'm going to take 1.28 divided by 0.03. 1.28 divided by 0.03 equals
42.66667 eventually.
Yeah, and that's in that domain 30 to 60. So now, how do we figure out the answer?
Technically, we can just plug it back in, right?
Right. So we want to take L of this number.
Okay. So it's
I can
do
that probably easier here.
Yeah.
Ooh. I left that 0.015. Oh, because it is. Yeah. What was this number again?
42.666.
42.666 quantity squared plus 1.28 times 42.666 minus 7.7. So the answer should be 19.607. That it?
Yeah, we could click on the next one, and if it doesn't look like it's a multiple choice or whatever.
This shouldn't be that hard. Let's think about this for a moment. Find non-negative numbers x and y that satisfy the given requirement. Give the optimum value of the following expression. Okay. This is actually a more typical problem also. Well, first of all, if x plus y equals 87, what's y equal?
-87 minus x.
Substitute the result from part A into the equation p equals x squared y for the variable that is to be maximized. So p would equal what?
87.
Well, start with the x squared.
X squared y minus 87, or 87 minus y.
87 minus x. In other words, we want to get this p down to one variable, not two. We can't differentiate it if it's got two variables in it. We can only differentiate it if it's all in one variable. If I want to take dp dx, then it has to be a function of x. So that's why we solved for y, so that we could substitute a function of x for y. And now if I simplify that, I get 87x squared minus x cubed. Find the domain of the function p found in part B. Well, here's p. Are there any restrictions on my domain?
Where am I looking again? Very bottom one?
Yeah.
0. Zero, zero, then?
Well, it looks like negative infinity to positive infinity. But it isn't, because I have to pay attention to that equation right there. And they want non-negative numbers x and y. So x certainly cannot be negative infinity. In fact, x can only go from 0 to 87. Because the moment if x were to go to 88, it would make y negative, right? Right here. X is 88, y is negative. And we are to find the non-negative numbers that satisfy these. So I would say 0 to 88. Type your answer in interval notation. 0, 87. That's the domain of that function.
And it's just...
To determine the domain, find the interval for x that will produce a value for p greater than or equal Do I need brackets instead of parentheses?
Oh yeah, it says because it was greater than or equal to is what that hint gave you. So maybe just on the left side for 0.
Well, it should be able to be 87 also.
There we go.
You see why? Because if x is 0, y is 87. And if x is 87, y is 0, and all of those are okay. Find dp dx. Well, that's pretty easy. If this is p, what's p prime?
Would that... Whatever 87 is times 2x, 174x minus 3x squared.
Solve that for 0. I don't think they want me to solve this yet. We got to put in this 174x minus 3x squared. Now solve the equation letting dp dx equal 0. So solve this equation.
So 174 divided by 3, can you do that?
Actually, a number is divisible by 3 if the sum of its digits are divisible by 3. So 1 plus 7 plus 4 is equal to 12, so yes, you can do that.
It's 49.
So if I take out a 3x, I'm left with 49 minus x. So my two solutions are x equals 0 and x equal 49.
Alright.
It's not 49.
It's 7.
It's 59. 174 divided by 3.
Oh, I did 147.
58.
There we go, my arithmetic striking again.
Well, better your mistake than mine. I feel terrible when I make a mistake like that. Okay, so what is P of 0?
P of 0 from the last equation?
Well, here's P up here. So
0.
0 is 0.
Okay.
P of 58.
87, 58 to the what? What power is the equation to?
It's 87 times 58 squared minus 58 cubed.
$97,556.
97. What are the
556?
556? And finally, P of 87. Huh. I can do that one in my head. 87 times 87 squared minus 87 cubed has to be 0.
Yep.
Give the maximum value of P as well as the two numbers x and y whose product is that value.
So the maximum product of x and y would be the 9,001, so y would equal 58.
No, that was x. X would equal 58.
Okay, and then y would equal 9,000,
No.
97,500.
No, if x is 58, y has to be 29.
Oh. Okay. Yep. So 5829.
Yeah, 58 times 29 is what? 1682. Now, one thing I am wondering is, do they want x squared times y or do they want x times y?
They'll give us 2 shots, so
State the largest value from part E.
so that'd be 97,556.
Not. I think they have a little glitch there.
Yeah, I was just.
'Cause I don't think that's the maximum product of x and y. That is P of 58 plugged into x squared times y.
I wonder what.
Values of x and y that have the maximum product are x was 58 and y was 29, right?
Yeah. Oh, and you know what? I just went and plugged in 59.
Uh-huh.
And it's 97,468. So 58 is the biggest.
Yeah. Yeah. Yeah, these are classic optimization problems where this could easily be, oh, a fence, trying to figure out the area of the fence or something. I don't know. But fence problems are always like this. If you have a fence problem, you know what the perimeter is and you know what the area is. It's X times Y. So using that information, you can figure out how to design your fence so that you get the maximum area. All right, so we're going to stop there?
Yeah.
All right, so I need to save this.
Yes, please.
And does it log out? No, it doesn't log out automatically. I need to sign out. Okay. And let's see. We are scheduled for 5 on Thursday. Can I make that 5:15? Does that screw you up at all?
No, not at all.
Let's make that, if that's okay with you. I think I'm going to be home by 5, but I want to give myself extra 15 minutes. I'm playing golf at noon, and I'm only 15 minutes away. So that 5:15 should definitely work.
Okay.
We'll plan on 5:15 on Thursday, and we'll pick up from where we left off.
All right, works for me. Thank you.
All right, Sean, you're welcome. Bye-bye.